Welcome to Gurukulplex Education's video on the topic of materials. Metals and non-metals. This chapter examines the physical and chemical properties of metals and non-metals, how they are acquired by metallurgy, and how metals combine with oxygen to form metal oxides. We are delighted you are joining us as we uncover the newest in materials science together. Let's get started. We will be discussing materials, focusing on metals and non-metals. Out of the 92 elements found in nature, 70 are metals and 22 are non-metals, with the remaining being metalloids which have characteristics of both metals and non-metals. Gold, silver, and platinum are metals found in the free state, while most metals are found in the form of oxides, sulfides, carbonates, silicates, and others in their combined state. Non-metals can also be found in the free state, with examples being helium, neon, and argon, and some such as sulfur and phosphorus can exist as either free or combined states. Metallurgy is the science of extracting metals from ores and purifying them. Minerals are naturally occurring substances containing one or more elements or their compounds, with ores being a mineral from which one or more metals can be extracted profitably. The process of metal extraction and purification from ores consists of three main steps: concentration of the ore, reduction of the metal compound, and refining of the metal. Concentration is the separation of minerals from impurities, reduction is the process of obtaining the metal from its compound, and refining is the purifying of the impure metal to obtain a pure product. Metals and non-metals are essential components of many materials utilized in our life. Metals are distinguished by their solid form, hard nature, metallic luster, high specific heat and boiling points, malleability and ductility, good conductivity of heat and electricity, and sonorous properties. Conversely, non-metals can be found in solids, liquids, and gases, are brittle, have dull luster, low melting points, are non-malleable and non-ductile, bad conductors of heat and electricity, and non-sonorous. Metals generally react with oxygen to produce basic metallic oxides, which then react with water to form bases. Magnesium, for example, reacts with oxygen to form magnesium oxide, which when reacted with water produces magnesium hydroxide. Non-metals, in contrast, react with oxygen to form acidic non-metallic oxides, which when reacted with water form acids. Sulfur, for example, reacts with oxygen to form sulfur dioxide, which when reacted with water forms sulfurous acid. Metals have distinct behavior when they come into contact with water or acids. When exposed to water, metals generate metal hydroxides and hydrogen, like with sodium where it produces sodium hydroxide and hydrogen, or magnesium creating magnesium hydroxide and hydrogen. For non-metals, it's uncommon for them to react with water. Exposure to acids results in the production of metallic salts and hydrogen with metals. As an example, when zinc interacts with hydrochloric acid, it creates zinc chloride and hydrogen. Non-metals, although exceptions do exist, normally don't respond to acids. Metals and non-metals are distinct categories of elements that possess varied properties. Metals can act as a substitute for other metals when exposed to a suitable reagent. This is due to the varying reactivity of the metals, which leads to the order in which one metal can replace another in a salt solution. For example, magnesium is more reactive than copper, hence it can replace copper from copper sulfate solution to form magnesium sulfate and copper. Similarly, zinc is also more reactive than copper and will replace the copper when placed in the same solution. Finally, iron is even more reactive than copper and can replace copper, which in turn yields iron sulfate and copper. These reactions illustrate the reactivity of metals and how they can be arranged in a certain order according to their activity. The activity series of metals is a concept that orders metals based on their reactivity, starting from the most reactive, potassium, sodium, magnesium, to the least reactive, gold. This is an important concept when considering the reactivity of elements, going from aluminium, zinc, iron, lead, copper, silver and gold. Reaching a crucial part in our video, Materials can be classified into two broad categories: metals and non-metals. One of the sub-classifications of metals: noble metals comprise metals such as gold, silver and platinum which don't react with air, water or acids, making them highly desirable. Gold is a soft metal and so it is usually alloyed with silver or copper to make it harder. This 24-karat gold is then used to make ornaments. Metals have become an integral part of our lives, used for a variety of purposes. Iron is used to produce pins, nails, tools, machines and bridges, while aluminium is used for utensils, wires, furniture and aircraft parts. Copper is used for making wires, vessels and electrical gadgets. Gold and silver are commonly used to create jewelry, coins and medals, and platinum is used in jewelry, electrical gadgets and plugs in vehicles. Sodium and calcium compounds are used as common salt and chemicals, respectively. Non-metals are a varied set of elements with a range of uses. Sulfur finds its primary application in the manufacture of sulfuric acid and metal salts. Oxygen is a basic requirement for breathing of living things as well as ignition of fuel. Nitrogen is used in the production of ammonia for fertilizers. Hydrogen, likewise, has numerous uses, including production of ammonia for fertilizers, fuel for rockets, and welding. Chlorine is employed as a germicide in water, while iodine is used in tincture iodine, an antiseptic. Alloys are combinations of two or more metals or a metal and a non-metal in a homogeneous mixture. Alloys are created to improve the properties of a metal, such as strength or corrosion resistance. Steel is an alloy of iron and carbon and is often used for the construction of tools, machines, vehicles, ships, rails, buildings, bridges, and dams. Stainless steel, a combination of iron and chromium, is frequently found in the creation of utensils, cutlery, and surgical instruments. Brass, a combination of copper and zinc, is used for utensils, handicrafts, and musical instruments. Bronze, an alloy of copper and tin, is used for making statues, medals, bells, and ornaments. Alnico, an alloy of iron, aluminium, nickel, and cobalt is used to create magnets, whereas duralium, an alloy of aluminium, copper, magnesium, and manganese is used to make utensils, pressure cookers, and parts of vehicles and aircrafts. Metals can be prone to corrosion when exposed to the elements. Preventive measures include applying oil or grease, painting, galvanization, electroplating, and alloying. An example of alloying is stainless steel, a combination of iron, chromium, and nickel, which is resistant to corrosion. Take 3 test tubes and put 1 iron nail in each. Place some anhydrous calcium chloride in one test tube to absorb moisture, some boiled water from which dissolved oxygen has been removed in the second test tube, and some water in the third test tube. Cork the 3 test tubes and leave them for 3 to 4 days. We'll observe that the nail in the first and second test tubes have not rusted, but the nail in the third test tube has rusted. This experiment highlights the importance of air and water in the rusting of iron. That's all. Thank you for joining us.